In the last lecture, we started with the denial of service attack. Denial of service is the way of making a system to not to respond to the client's request. Here, the system means the system may be a server system, maybe a normal computer, or maybe a network device that is available in the network. So, the denial of service can be performed at any level of the TCP/IP protocol stack. We have seen that this can be performed at any level of the protocol stack. In the today's lecture, we will see how this particular DoS attack can be performed at by considering various levels of the protocol stack. So, in this lecture, we are going to focus on the denial of service categories and denial of service attacks and how these particular attacks will be performed with some examples. In the last lecture, we started with the discussion of TCP communication, that is a three-way handshake communication of the TCP. The reason is, in the denial of service, whatever the application that you will be used at the application layer will mainly uses the services that are under the application layer. That means that are the services that are running under the application layer, such as transport layer and network layer. Then only the application can deliver its services. So the next to the presentation layer in the TCP/IP protocol stack is transport layer, in which we have TCP protocol and UDP protocol. And below to it, there is a network layer in which we'll be having ICMP protocol, which will help the IP protocol to work. So, in the denial of service, the attacker will mainly target the TCP, UDP, and ICMP. Whereas UDP and ICMP don't have any particular state information, especially the UDP is connectionless, where in case of TCP is connection oriented. Many of the applications such as HTTP, FTP, and regularly used applications at the application layer will use TCP as the underlying communication service. So that is the reason the attacker will mainly focus on the TCP communication. So that means here DoS attack can be launched with the help of TCP or UDP or ICMP. If you can understand the working procedure of TCP, UDP, and ICMP, you will get a clear understanding of how this particular DoS attacks can be launched. And if you know the tools, as I have discussed in the last lecture, the tools such as Nmap or HPing3 or NetWorks, NETWORX. These are the various tools, open source tools that are popularly used for conducting this kind of attacks, and also not only conducting but also fabricating our own packets and can send to the target system for launching of the DoS attacks. In this lecture, we will see some aspects of this, how we can send the packets to the target system with the aim of performing the DoS attacks. In the last lecture, we have seen TCP three-way handshake. The ultimate aim of DoS attack is to not to respond. The target system should not be responded to the client's request or any request. In order to do that, the first thing what we have seen is memory overfilling or memory overflowing or strucking up of the computer by opening of many memory connections. These are the things we have seen in the last video. For that, this TCP, the innocence of the TCP three-way handshake will be used and exploited. How? It will be done like this. Here the client will be there. The client, what he will do, assume that this client in general is a genuine client, whenever the client sends the synchronous request to the server, in response to that synchronous request, the server will respond with synchronous acknowledgement. Whenever it receives the synchronous acknowledgement, then the client will establish the connection. Whenever the client is established the connection, obviously some memory will be created and allotted in the RAM of the client for maintaining the connection. Okay, this particular connection will be this our memory is created and maintained once the client receives the synchronous acknowledgement. But in case of server, whenever a synchronous request was received, automatically the state of the server will change to the synchronous received and a memory will be created. This memory is a half opened connection, we can say. This memory will be created and will wait for the client to respond with the synchronous acknowledgement. That is the acknowledgement signal. So this particular memory will be created and will be retained in the server for at least 70 seconds. For at least 70 seconds. Assume that in that 70 seconds, instead of innocent client there, assume that some attacker is there. In that 70 seconds, if the attacker might have flooded where the number of synchronous signals, it may be the number of means thousands of synchronous signals in that 70 seconds, then obviously this memory retaining for every connection will be doubled by 70 seconds. Thereby, as many number of synchronous signals that is coming into the server multiplied by 70 seconds, that means how much time that particular the connection need to be retained. The connection need to be retained. The time will be exponentially increases. Thereby, the occupancy of the memory will be for long time, so that the server system may not allot memory for the new requests, which are, we can say, genuine requests that are coming from the original clients. So this is the way how this particular DoS attack will be performed by continuous synchronous flooding into the servers. So that is the reason many of the servers will stop this particular request at the firewall level itself. They will write some firewall rules at the server so that this particular way of synchronous flooding can be avoided. Actually, this synchronous flooding or flooding of the packets can be done with the various echo services. Either maybe synchronous of the TCP or UDP echo or maybe ICMP echo. Usually, you are aware of this ICMP echo will be performed with the help of the ping command. Ping command will send the ICMP echo request, and help of the ICMP echo request, the servers will respond with the information that okay, the system is live. So now let we'll see one small example. Now we'll consider our university system. I want to ping our university system. For that, for example, ping www.google.com. Now the pinging is going on here. Okay. So here the Google is using IPv6 and will giving you the response. And the time taken for giving the response is 48 milliseconds, 89 milliseconds, 55 milliseconds, 72 milliseconds, like that. Now what I will do is I will try to ping our university system www.jit.ac.in. So the pinging to the web server jit.ac.in now request a timeout. But if I run jit.ac.in in the web browser, the university website will be displayed. But here I am not getting the echo reply. The reason is the server have some security rules might have placed by the administrator that it should not respond to the echo ICMP echo request. Whenever they said that okay, ICMP echo request should not be responded in the firewall rule, then obviously the system, even though system is live, it will not respond to the ICMP echo request. It is especially will be done in order to avoid the flooding attacks. This is a safety measure that will be taken by many of the servers, especially to avoid the echo flooding or synchronous flooding and this kind of flooding attacks. Whenever these flooding attacks were happened, what will be happening? The ultimate aim of the flooding attacks is to perform the DoS attacks. So this DoS target will be done in several ways. The DoS targets are, especially why the hackers will perform these DoS attacks. They want to bring down the web server down. So the web server is the main target. Attacks performed targeting the web server mainly to increase the downtime. Many web servers will promise you that they are going to provide the web services for 24 by 7, 365 days. But whenever the downtime of the servers are increasing day by day because of these DOS attacks, then obviously the reputation of the servers will decrease. Our reputation who is providing the servers will decrease. Thereby, there will not be any business. Ultimately, it will lead to huge financial loss. And next one is not only web servers, but also they will target this DOS attacks for backend resources. Their front end means the web application that you see from the web browser. Backend is the database. Here attacks performing targeted database servers, because whatever the in a dynamic web application, obviously databases having a major role. Whenever the database servers are down, then we can say that the databases will not respond for a long time. Ultimately, whatever the request given by the user will not be will not come out. Especially, it is just like after writing your plus two or some other competitive after writing the competitive examination, when the results were announced, you want to check your result. Sometimes when the system was launched, the results were launched just now within 5 to 10 minutes. Because of the huge requests that are coming onto the database servers, the servers will not respond as expected. So it is just like creating more congestion onto the database servers by sending the continuous queries. Thereby, the database servers will not respond to the level expected. Next one is network or computer specific uh, things, such as the attackers perform targeting the network devices in a LAN. The network devices may be the routers, or maybe the switches, or maybe any other intermediary devices that are available in the network. So because in the router also there will be routing table, some memory will be there. So the attackers will also try to attack the routers. Thereby the memory available in the router may be exhausted, so that it may not include in the memory. So this is what the ultimate aim of are the targets of the denial of service attacks. So DOS and DDoS attack categories. The how many ways? I told you in the last lecture. DOS is a DOS is a wide topic. Okay, DOS attacks can be performed from in many ways. There is no specific way to create a DOS attack. Ultimate aim is to not to make the targeted computer to function. This is what the ultimate aim. So in many ways, this particular DOS attack can be performed. So attacking categories are like this. Volumetric attacks. These attacks focus on consuming the bandwidth. To do this, attacker sends high volume traffic to the server. So whenever a bandwidth is allotted to you, there will be like a uploading width and downloading width. That means always the bandwidth is of two channels. Okay, upload and download. So they will block either upload or download. Especially the people will require, in general, the users will require the download bandwidth. So they will try to block this particular download by sending unnecessary huge traffic onto the bandwidth. Thereby, the bandwidth limit will be exhausted. Thereby, the service will not be provided by the system. So, the volumetric attack, these attacks focus on consuming the bandwidth. This attacker sends high volume of traffic to the server. The best example of doing this is repeated TCP connections. Just now we have seen the previous slide that repeatedly sending the synchronous signals for the establishing of the TCP connection. Next one is synchronous attack or flood, ICMP flood, ping of death. These are the various attacks that can be performed, or that are various activities that can be performed in order to get this particular volumetric attacks. Next one is fragmentation attack. Fragmentation attack is a one category in which an IP datagram is divided into small fragments and sent through routers. To reassemble these fragments, routers require more resources. Teardrop attack is a good example of it. Fragmentation attacks can be done from the TCP point of view, which is called TCP fragmentation attack, and also from the UDP point of view, which is also said to be UDP fragmentation attack, and also from the ICMP, which is also called as ICMP fragmentation attack. This UDP fragmentation attack is also said to be Fragile attack, or the ICMP attack, ICMP fragmentation attack is also said to be Smurf attack. Actually, what is the fragmentation? First, we need to understand the fragmentation. See here the general functioning of the protocol, the innocence of the general functioning of the protocol, by trusting the sender and receiver are trustworthy. By taking the advantage of this innocence, the attacker will try to exploit that innocence. So thereby, these attacks will be performed. What is meant by fragmentation? Fragmentation means whenever huge traffic is there, which is passing through the routers or many other network devices, automatically there will be a congestion. It is just like the bandwidth of a road is very narrow. That is, the width of a road is narrow, but heavy vehicles are coming onto that road. Automatically, there will be a congestion will be formed. In the same way, whenever the bandwidth of the network devices or servers are very somewhat narrow, or bandwidth is available, but if you are trying to send huge traffic into that particular way, then automatically the congestion will be formed. Whenever the congestion is occurred, sometimes for the regular and genuine traffic cannot pass through that particular route. So thereby, sometimes what will happen? The packets will be dropped. So because of the congestion, the packets will be dropped. So when the packets are dropped, if it is a connection oriented like TCP, again the same packet will be retransmitted. But in case of UDP, since it is connectionless, once the packets are dropped, That's all. We cannot retransmit the packets. So, but in TCP, what will happen is congestion will be understood by the TCP congestion control protocol. Thereby, what will happen? The TCP will use a special mechanism called windowing. Based upon the congestion which is ahead of the transmission, first of all, that TCP protocol will understand that what is the congestion available in the next router. If it found that there exists congestion, then the window size will be readjusted, which is called sliding window protocol. This sliding window will be done based upon the congestion that you find in the next network device in the data transmission. So here the TCP will adjust according to the congestion which is available in the next upcoming router. So this way of window adjustment will be done. In the process of this window adjustment, they may, if it is TCP, they will do the window adjustment. If it is UDP or ICMP, what it will do is to pass through the congestion. So see, look at if the road is very narrow, or if the road is very narrow, And if there are heavy vehicles, it is very difficult to pass. But if you look at in a traffic jam also, the cyclists or bike riders, they will go in a narrow way, and even though they will find some space in that, and they will pass through. So the reason is the vehicle is very small. So in the same way, in order to pass through the congested uh, route, what the uh, what the previous devices will do is whatever the packet it comes, whatever the IP packet or whatever the any other datagram packet it receives, it will divide into small chunks. These small chunks which can fit and pass through that route, that chunks are said to be fragments. Okay, these fragments, whenever it cut into small chunks, these fragments will be labeled with some sequence numbers, and there will be some offset number will be there, and sequence numbers will be there. But in case of this fragmentation attacks, what will happen is once you perform the division into the chunks and creation of the offset, then if you might have released out, then the next communicating device, either it may be router or any other thing, whenever it receives those fragments, it has to allocate some buffer to that fragments to keep, because you cannot assure that the fragments cannot be received in the same way as they have sent by the sender. They may come in any order. First fragment may come, next maybe 100th fragment may come, next 50th fragment may come. Like that, it may come in any order. But every fragment will be having what is the starting fragment number and what is the end fragment number and what is the offset. So based on that, the receiving device will create some memory or some buffer. Why this buffer is maintained? Till it receives all fragments, it cannot reassemble. That is the reason it will keep a buffer and will whatever the fragments it receives, it will keep all the fragments in the buffer. Once it receives the last offset or last fragment, then all the fragments that are kept in the buffer will be taken and will be rearranged to get the original IP datagram. Okay, so what will happen in this attack is once the fragment sequence numbers were wrongly written or offset is wrongly written, what will happen? The buffer will be maintained till the fragment come into the receiving device. Or even though all the fragments are received, if the offset is wrong, the rearrangement will fail, thereby the device may collapse. So this is what the ultimate aim of wrong offset and wrong sequencing fragmenting technique that is followed by the attacking system to send by mentioning that some congestion is there, and in the at the receiving end unnecessarily buffer will be maintained, which is a overhead for that particular device, and also the rearranging of the fragments, if there some mistake was happened in the rearranging of the rearranging of the fragments because of the offset or maybe of sequence number, then it may lead to the crashing of the system. This is what the ultimate aim of the fragmentation attacks. So these fragmentation attacks can be performed with the help of TCP or UDP or ICMP. If it is done via UDP, then those are said to be Fraggle attacks. Especially here, UDP echo request will be sent like that. And in case of it was done with the help of ICMP, then that is said to be Smurf attack, which is possible via ICMP echo attacks. On to the next topic, which is a TCP state exhaustion attack. This is a one variety. In this, the attack focused on the damaging the state information maintained by the servers, because whenever a server is providing the TCP service that is offered by the application layer, it may be a HTTP service or it may be FTP service. Whoever requests for the TCP service, their state information or connection information will be maintained at the server level. Here, this TCP state exhaustion attack will target on the damaging of the connection status, which is maintained by the server. This attack focuses on damaging the state information maintained by the servers. thereby servers forget the concurrent connections that are connected to the server. So it will forget, because when the connection state information is gone, that's all. The connection information also gone. Next one is application layer attacks. Usually the application layer attacks are targeted to degrade the service ability of the applications that are running at the application layer. Usually it will be done with the uh, by identifying the flaws, in the software that they have developed. By understanding the software flaws, they will try to launch this particular application layer attacks. Any of the DoS attack will be performed either in these four ways. Okay, but the type of the attack, or the attacking area, or we can say attacking area, will give you the attacking area means here area in the sense the layer of the protocol stack. Depending upon the layer of the protocol stack, and depending upon the depending on the service they use, or depending on the logic they use, the attack nature will differ, and thereby we got different attacks to perform this denial of service attack. Now we'll see one by one how it will be performed. And in order to understand this thoroughly, what I will do is I will show you one example. Here, this is the Oracle Virtual Machine. The one who have not set up their Quick Virtual Lab may go to the Quick Virtual Lab video and can set up their own virtual lab. So here, this is the Oracle Virtual Machine Virtual Box Manager, in which I have several operating systems. One is a service security operating system called Kali Linux, and here Windows 7, Windows XP, Metasploitable 3, Vulnerable OS V2, and Web for Penetration. These are the various vulnerable operating systems that I have installed. On Windows 7 and Windows XP, I have installed the vulnerable applications. Basically, Metasploitable 3, Vulnerable OS V2, and Web for Pentesters. These are the by default vulnerable operating systems. So, in this Windows XP is there. This Windows XP vulnerability, by installing the vulnerable applications, I have provided the link under the description section of the quick virtual lab setup video. You may download that link, this Windows XP Oracle Virtual Machine image from that link, and along with this, you can also download Metasploitable 3 from that link. And vulnerable OS V2 and Web for Pentester, for this, the links are provided. You can download from the links, and you set up the lab that I have provided with the help of the instructions that I have provided in the quick virtual lab setup video. So here I am running Kali Linux and Windows 7. So this is the Kali Linux I am using. This Kali Linux is 2020.3. Okay, this is a somewhat recent Kali Linux version. So here I am using this Kali Linux, and I am taking Windows 7. So here Windows 7. In this, you look at. Let us see the command ipconfig. I have dedicated, that is, I have allotted an IP address which is a static IP address 192.168.1.4 to this Windows 7 operating system. Now, from Kali Linux, what I will do is I will perform the Nmap scanning, because Nmap is a very powerful tool that will be used for getting the technical information of a targeted computer. Here, whenever I say target computer, the attacker who will target for a particular computer, or a computer which is supposed to be compromised by the attacker. In this, there is a scan called reason scan. If you perform the reason scan, on what basis, for what purpose, or on what basis that particular computer responded to the Nmap request, will be shown to you. Nmap reason. Okay. So IP address of the Windows 7 operating system is 192. 168.1.4. So it will take some time, maybe 10-20 seconds it will take to perform the that is sending of the request to the Windows 7 and giving you the result for what for the particular on what basis that Windows 7 was responded. Now the result we got, Nmap scan report for 19.168.1.4, host is up, that means the system is live, received connection refused, next not shown, 989 closed ports are there. Reason is 989 closed ports refused the connection. That is the reason we are unable to display these ports. But 80 is the port which is on the HTTP, which is running for the HTTP service, which is again of the TCP type, is responded. So the reason the state is open, and this was responded with the help because of the synchronous acknowledgement signal. Okay, how the Nmap come to know that this particular port is open? This particular port is open because this Nmap received a synchronous acknowledgement signal. That means Nmap might have sent a synchronous signal. Nmap might have sent a synchronous signal, and in response to the synchronous signal, Windows 7 might have sent a synchronous acknowledgement signal. That is the reason. That is the reason it come to know that okay, port 80 is open, and not only port 80, port 135, 139, 445, and remaining many other ports which are binded to TCP services. So which are binded to TCP services are responding because of this synchronous acknowledgement. You look at because of this reason. Okay, because of this reason, we come to know that these ports are open and can be available for are listening to the new connections. This is what the thing that we can find with the help of Nmap. So far, whatever we have discussed, just we have realized it with the help of Nmap, right? Next, we'll see the next concept. DoS or DDoS attack techniques. Here, service request floods. The first way is to provide the service request, that is by asking for the opening of the TCP connection or TCP services or something. So requesting for services to web applications and not acknowledging the response. The same thing we have seen in the TCP three-way handshake also. And next one is synchronous flood attack. Whenever the synchronous flood attack also is performed, in this the attacker attempts to send synchronous signal or synchronous request with bogus IP addresses. That means some fabricated IP addresses will be used to send the synchronous signals. The reason is if the synchronous signal is continuously received by the server from the same IP address, then the security systems like intrusion detection and prevention systems or maybe any other security alert systems which are present on the server computer will identify that okay, from this IP address many synchronous signals are coming. So that means that this particular IP address is trying to attack my computer, so it will block that particular IP address. That is the reason what the attacker will do is he will go for a trick by sending the synchronous signals with bogus IP addresses. For this, you need to fabricate the synchronous signals by using either HPing3 or NetWalks tool, and you are supposed to send it. Next one is ICMP flooding attack. ICMP is a helper protocol to know the status of the root, errors, and device operations from the routing devices. Hence, flooding the ICMP request will not give enough time to respond by the devices. Either this synchronous flooding or ICMP flooding, once the continuous flood of synchronous or something is coming into the server don't have time to respond. Whenever it don't have time to respond to the incoming flood of synchronous or ICMP, obviously it don't have time to respond to the original request also. So that is the reason this ICMP flood attack will be performed. In order to do this ICMP flood attack, we may use HPing3 tool for this purpose. Let us see in the Kali Linux, hping 3 sudo hping 3 hyphen help. This hping 3 has many switches. The switches in the sense here many options are available with the hping 3. You look at these are the usage hping 3 host and several options. These are the various options available. Now what I will do is I will try to send an ICMP flooding attack onto the Windows 7. So for that, I need to use a mode, whether you want to use the raw IP or ICMP mode or UDP or scanning or listening. So I am using ICMP mode for sending the ICMP echo request. So whenever I send the ICMP echo request, then this particular Windows 7 will give the response of whether it is responding to the ICMP echo request or not. So for that, what I will do is, and at the same time, please remember Nmap and ICMP, that is hping 3, will send a huge traffic, will generate a huge traffic over the network. So by observing that with the help of any network sniffing tools like TCP dump or WinDump or Wireshark, we may use at the target computer by the security analyst. They may monitor the traffic which is coming into the computer. If the traffic that is coming into the computer is found to be abnormal, then the security engineer or security analyst will identify that some attack is going to be targeted on our computer. So for that, what you will do is you may go to this WinDump website. WinDump is the TCP dump version of the Windows. You may download this WinDump, and basically this WinDump or Wireshark, these two will work on the top of the WinPCAP. WinPCAP means Windows Packet Capture program. So once you download this, after downloading this, first of all you need to install this download WinPCAP. Here the download WinPCAP is there. You are supposed to download it. Download WinPCAP. So here downloading will be done. Here installer for Windows. You install it first on the Windows 7 operating system, and then you install this WinDump. Okay, so this WinDump you can run from either you are supposed to run it from the command prompt, and automatically it will listen to the network interface that is available with the Windows 7 and will show you the traffic which is going on. So I have already in WinDump on my computer, that is there in the user folder dir. So here you can find WinDump. So now what I will do is I will run WinDump. Now this WinDump is listening to the network interface. Currently no traffic is going on. General beckoning will go on. This general beckoning is nothing but general hello packets. Usually the computers will exchange the hello packets to maintain the routing table or to maintain this ARP tables or something. So like that, since it does not it is not sending any it is not receiving any hello packets or something. The reason is nothing was sent by the either any of the computer which is connected in the network. Now what I will do is I will make a ping 192 dot. I will type this 192.168.1.4. So that means you are going to send the ICMP echo request. So let us see here some traffic is going on. Okay, some request ICMP echo request is coming from the so and so Kali Linux, and with that IP address of the 1.1.3.33. So it is giving you the traffic like this, right? Now, if you are using the hping 3, you are supposed to launch this ICMP flooding attack with the help of the following switches like this. You are supposed to use sudo hping 3 -1. That means 1 is the mode which is for the ICMP mode. So for this sudo So that means here -1 is the ICMP. Here targeting the port 80. By targeting the port 80, -S means a synchronous flood. Synchronous flood sent. Look at this is synchronous flood. Huge flood was going on. It is unstoppable flood. And if you observe via task manager, the CPU utilization will go up to 40%, 50%. The reason is the CPU is responding to this replies heavily because the heavy request is coming into the heavy flood is coming into the system. So in order to conduct this ICMP echo request, the command that what we have used is hping3-1 is for the switch to choose the ICMP. -P is for the port on which you want to target. The -S means the synchronous flood, and on the IP address 192.168.1.4, which belongs to Windows 7, on Windows 7 you are going to target the port 80 and sending the synchronous flood. And to observe that, you are supposed to install the WinDump on Windows 7. First, you are supposed to install the WinPcap. Then that WinPcap will capture the packets and will show you via WinDump. Thereby, you can understand that how much flooding is going on and all. So controls, if you control C here, so within a small time, you got 289 packets captured and 289 packets received by the filter. So perfectly, how many packets captured, that many packets were received by the filter. So that means it is very active in listening to the packets that are coming into the system. So this is the way you can realize the ICMP echo request. So this is thereby you can find we can launch the ICMP flooding attacks. So we'll see rest of the attacks, and with respect to the peer-to-peerness and with respect to the other layers of the protocol stack, how we can launch the denial of service attacks by identifying the flaws in the software. Okay, in the next lecture.